Today we have a 2007 GM cluster with multiple things going on with this one. This is originally a prior repair attempt because of the displays. And I guess during the process of repairing the displays during the prior repair attempt, the mile per hour stopped working. And also what we're going to be doing with this cluster today, besides fixing the mile per hour and the displays, getting a slight twitch out of the mile per hour. Let me open that up. We are also going to be doing an LED conversion. This one should be pretty cool when it's done. We're going to do blue for the scales, for the number scales, and then white. Originally these have red to light up the needles. This guy supplied some different needles, and they have a white insert. See if I can get this dang bag open here. Here. So they're chrome with a white stripe in the middle that should illuminate, and we're going to replace the red LEDs with white LEDs, so they should light up white, and then we'll have the blue scales. And if you notice, right now, this thing is causing my power supply to cycle. See, it's hitting the current limit. This is set to a little over an amp. This cluster should only need, I don't know, less than an amp to turn on and boot up and work. It's kind of stuck in it's forcing itself into a boot cycle here. Something must be shorted with that display circuit, because when the display is supposed to pop up, it's just shutting down. It's causing a short. It's overcurrenting the power supply. It's shutting down, and then of course, because it shut down, it reboots itself back up again. So, all right, I think maybe we can get started here. Let's pop this cover off. See if I can figure out what's going on with the mile per hour and why that is not working. Is it just, ooh, wow, that's really tight. That's not dragging on the, oh boy, yeah, somehow this guy managed to, it's all kinds of chunks. Oh, yep, okay, it's bad. Yeah, it should be nice and smooth like this. See how nice and smooth the RPM is? The mile per hour is just crunching. All those gears have been just funned up. Oh, wow. Oh, there, yeah, okay, let's replace that stepper motor. How the heck did he do that? Because they mean, well, let's proceed, shall we? Let's just pop these needles. These needles are pushed down a little too far. I can't even get the tool in there. One thing to watch out for, guys, when you're doing the self-repair attempts, don't push the needles down so far that they drag on the face. That's too far. I mean, this mile per hour one is down too far, but we have more going on than just the needle dragging on the face. Those gears are toast. Those gears are messed up in there. So, yeah. Oh, yuck. All right. Look at that mess. She got hot and burned itself up. Not the prettiest. Well, I guess that explains why it's causing a great big short when it tries to turn on. Some of the burnt board, it can become conductive when it carbonizes like that, when it gets that burnt, so I might have to cut some of that away. It's basically a giant short circuit, or potentially could be a giant short circuit under the MOSFET, and there might even be a hole in the new MOSFET. Well, let's start by gutting this and starting over, and maybe with some fingers crossed it can live again. Backside just has a little bit of a dark spot, but that's because this board's been through a lot. Anyways, let's go. Here I'm lifting the pin of the transformer. I just want to isolate it from the burned area. And here I'm cutting the trace that would usually go to the gate of the MOSFET, but now it just leads to the area that's all burnt up, and I want to isolate that also. All right, let's check for display fan spin, shall we? Now, if this is a good repair and if there's no other damage, say to like the transformer, make sure it doesn't have shorted windings or anything, we should be drawing about 700 milliamps under normal conditions. First, I'm going to power it up, see if it even comes alive. And hey, good, we have displays back. And we have 900, 800. Yeah, okay, looks like the current's kind of settling. Typically around 700 is where it should be. Maybe it'll settle down around in there. Maybe I'll double check to see what a good one runs. But even if it is 100 milliamps over, I'm not alarmed. Yeah, it is settling down. Oh, nope, kind of jumping back up again. Anyways, it's working. What I might do later, I may or may not get it on video. I'll probably slip some Captain tape under the MOSFET, and then I have heatsink thermal pads, those soft, squishy, gummy kind that I usually stick on top and stack a couple up there to give a little extra heat sinking. Let's get this bad stepper motor out of here. I became curious what the current draw is on a original unmolested cluster, and this one's straight from the yard, but as far as I know there hasn't been any shenanigans done to it. If I can find a dang plug. Come on, plug. Let's check the current draw, and now it's fully booted up. Okay, 850, 800, yeah, I guess we could say 800 milliamps is a normal current draw. Let's plug the board back in that we are repairing. And its current draw is going to be, we gotta wait for it to pop up here. A little over 8. 89, maybe we'll settle down. Yeah, it's in the 800s. I think we're okay. All right, let's move on to the next step, and that is we're going to swap out the LEDs. So here we have these aqua color original ones. We're going to make that a solid blue. And then here are the red needle illuminators. So we have 2 for the larger gauges and just 1 red LED to light up the smaller needles. So yeah, let's start pulling these off. All right, so I just finished the 1 gauge. I'm impatient and wanted to see what it looked like so we can compare, the factory original aqua and red to the blue and the white. And I think that looks pretty cool. A little bit more of a cleaner look, maybe. See what it looks like when the needle sweeps. Yeah, I think I definitely like the blue over the aqua. And that white needle is nice looking. So now I'm just going to repeat the same process that I did for this gauge to all of the gauges. It's all done. Do you want to see it? But first, see that TV sitting over there? That's a 50-inch Vizio 1080p smart TV that I picked up from a local recycle shop for about the price of a pizza. If you want to see me fix that, you'll just have to make sure to subscribe. And if you're already a subscriber, well, thank you. Let's see what this looks like. Yeah, I like that. Pretty slick. So yeah, we got a new stepper motor. Display is working. Got the new LEDs. Got the white needles. Looks pretty good. That wraps up this one. Thanks for watching.